we are going to do polyatomic ions. Okay, that's massively blurry. Okay, so polyatomic ions are similar to the ions that you met in Chem A. They're charged particles. They have gained or lost electrons to carry a positive or negative charge. Gaining electrons gets you a negative charge. Losing electrons gets you a positive charge. And polyatomic ions will also form neutral compounds. So when they get together with other ions, they will make compounds that are electrically neutral, meaning they have the same amount of positive charge as they have negative charge. Okay. Good. Okay. In the name here, polyatomic ions, here's your first clue that things are getting funky, because here we're going to have many atoms. These will be ions where many atoms form a group. Polyatomic ions rarely break apart. You can break a polyatomic ion, but you probably have to cook it pretty hard. Like, they're likely to stay together. So polyatomic ions usually stay together. Not always. We'll do reactions soon. You'll totally see reactions where you break apart your polyatomic. But typically they're going to run around in a little group. Okay. Okay. So in lots of chemistry classes, if you've had previous chemistry classes or something like that, you may have had teachers who were like, polyatomic ions exist and you have to memorize all of them. That's not this class. You do not have to memorize all of them. Some of them you will memorize because you're going to see them so much, you're going to be like, oh, I know what that is. Like, I've seen this enough times that I know what it is. But don't worry about it. You don't have to. Even if we were together in our physical classroom, this is one of the 4 pages that you could use through every single day, including the final. So the periodic table is one of them. Here's the second one, Chem A and Chem B. So this is a clickable link on the calendar that I showed you from the Zoom mini video. Okay. I have the whole thing. I would bookmark this in your tab. If you have access to a printer, go ahead and print it. If you don't have either of those things, that is totally fine. We're going to go through the anatomy of this, and your tests for today are to make sense of this page and then play a Kahoot game. And in the Kahoot game, you will simply figure out what's going on with this and just get the flavor of it all, right? So in my physical classroom, through all of Chem A, if you turn your periodic table over, you see this page of stuff, and for the most part, people are like, oh my gosh, what? Okay, turning that back over to the somewhat less scary side, the periodic table side. Great. Okay. Yes, this is a foreign language. You are in foreign language class. Okay. Okay, so click your tab, have that open in a different thing, because that'll be easier for you. We're gonna just randomly select polyatomic ion as an example. Here we go. We're gonna do hydrogen sulfate. Good. Okay. Okay, so we're gonna, I guess I can zoom this thing, huh? Yes, okay, so here's the entire thing that you have open on your other tab all together. This looks terrifying, but you're starting to notice some things. You know that polyatomic ions are many atom ions. each of these little circles is a polyatomic ion. So this is a many atom ion. It's these atoms, and it's got this charge. This polyatomic atom has these atoms, and it's got this charge. This polyatomic ion has these atoms, and it's got this charge. There's two things underneath all of these things. This polyatomic ion has these atoms, this charge, this name, and this formula. Think about that first. So if we do our hydrogen sulfate thing, hydrogen sulfate has one sulfur, but let's zoom. While I'm zooming, you stare at yours and figure out which atoms it has, what is its charge, and what is its name. So I randomly chose hydrogen sulfate, whatever. It's got one sulfur atom, 4 oxygen atoms, and a hydrogen atom. That little group, for the most part, is going to stick together. And when it's together, this thing can hold, it kind of happily holds, 1 extra electron. So that whole thing is a polyatomic ion. It's got the atoms, and then if you check down here, this formula is kind of a shorthand for it. It's got 1 hydrogen, 1 sulfur, 1 hydrogen, 1 sulfur, and 1, 2, 3, 4 oxygens. And that charge is right there. It's got a charge of 1 negative. If you are staring at this and you're like, why? Just why? Like, why is there an extra electron? Why is it these atoms? Why do some of these bonds look funky? Like, there's like this extra like little thing going on with bonds. Like, you may correctly point out that these are not double bonds because they can't be, and you are correct. That looks weird. There are resonance structures. There's a chance that you did resonance structures last quarter. If you did not, that's totally fine. I do not really cover them, so don't worry about it. They're super cool. If you're into resonance structures, we can totally go there. However, I don't need you to know them. So, but these like funky little bonds are resonant bonds. Yeah. The formula tells you which atoms. The name is kind of just the name. It just is the name of it. This picture shows you which atoms also, and there is the charge. Okay. I'm thinking let's draw one, just because why not? I'm going to choose one that you'll see a lot more than hydrogen sulfate. Let's choose carbonate. Now that I move my page. Okay. Carbonate, right there. This is a real popular polyatomic ion. In fact, and we could go through all of these, but your carbonate is also used in your favorite bubbly beverage. That is carbonation. So we'll just draw one example polyatomic ion just for fun. So an example polyatomic ion is carbonate. And again, you don't have to, like, you're welcome to memorize these, but you do not have to, because you can always reference this page. You're going to say, okay, carbonate has 1 carbon in the center, and it's got 3 oxygens. How, why, who figured that out? Why is this important? Why it's important has to do with conservation of atoms. You want to get your formulas correct, but do you need to know why 1 carbonate has 3 oxygens? You do not need to know why. But it's got 3 oxygens. Let's draw a picture. Although you don't have to draw the pictures even. You just need to know it's 1 carbon, 3 oxygens, and it's got a charge of -2. And that is a carbonate. So carbonate, 1 carbon, 3 oxygens, charge of -2. That's all. Another one that you'll see a lot is phosphate. You've heard of like this soap or shampoo does not have phosphates. Phosphates cause your ponds to get all gunky and gross. Your phosphate is located here. Same deal. Your phosphate has 1 phosphorus in the middle, 4 oxygens around the sides. Do you need to know how we came up with that? You do not need to know how we came up with that. As long as you've got this page and you can reference it, and you can say a phosphate is 1 phosphorus with 4 oxygens around the sides with a charge of -3, you are good to go. That is a phosphate. We could do another, nitrate. If you've got, sandwich meat, ham, turkey, whatever, flip that over to the ingredients list. And you're going to see that those probably contain nitrates. They help keep it like deli meat. What am I trying to say? Not gross. Whatever, they help preserve it. Preserve! There we go. Nitrate helps preserve your deli meats. Unlike cyanide, which is right here, if you've heard of cyanide before, that is cyanide. You can now draw a picture of it. That's an actual triple bond, by the way. But nitrate in your deli meat is 1 nitrogen, 3 oxygens, and a charge. They're polyatomic ions. Your charge is really important. Your nitrate has a charge of 1 negative. 1 negative. Okay. All right. So for today, what you're going to do is you're going to take this knowledge. I don't know why I put my carbonate so far away, but that's carbonate. And you're going to play Kahoot game. Because this is kind of just like learning the foreign language. Use your reference page all you want. Yeah, I'll get you the link for the Kahoot. Go ahead and name yourself something so that I know who you are, so that I can be like, yes, you got credit for your work. Play through the Kahoot game, and that's all. So preview to Friday, we're going to start putting our polyatomic ions into polyatomic ion compounds. Using all of this, if you watch the ions review video, we're going to do exactly this on Friday, except instead of monatomic ions with single atom ions, we're going to be using polyatomic ions, many atom ions. Cool, that's all. Have a lovely rest of your day.